Okay, we want to make a new video here for everybody who want to listen this. This is from Poro Ranch, the place that we had the worst spill in the history of the planet. In the history of the human. That was one of the worst spill that we have back in 2015. These people had to be evacuated at the time, all around this. They have from those mountains that you see over there, was the biggest spill that happened. And for several months, the people had to abandon this place over here because it was very difficult to breathe over here in this area here. So this is the place in which they impulse the Apollo programs, and they made the experiment with the rockets over there. Ben Brown from Germany was over here at the time, along with so many other scientists that they were doing the rocket that made possible, at the time made possible the walking in the moon. As you see, the beautiful mountains over here that we have, and the park that is building later on in this area over here, a lot of kids playing. The view is magnificent over here. Really magnificent view that we have over here. And at this time, I'm going to explain you about the origins, is the oxygen that we breathe. For this, we have to talk about the ocean too, because right there in the oceans where the second wave of the atmosphere took place. We have discovered later on with the big telescope that we have over here in the planet, around the planet, and satellites. We had those telescope over there. We discovered that in the formation of the star, especially in the Origen Nebula, we have one nursery of stars. Remember that the Milky Way have many different kind of these nurseries, big clouds like the Origen Nebula, and in this cloud we took the observations, and we saw how some of the stars, amazing how they form. And we saw when the star ignite, that means when the nuclear power start to make the explosion, the nuclear reaction that made possible the fuel for the stars. There is immense amount of is a burst water vapor that comes in the poles of the star, but immense. They calculate there was like all the oceans of the planet in one minute, like what burst from those poles of the star. I have to remember that the stars, a lot of the stars are big, much bigger than our sun, but the regularly, most of the stars are like our suns. A bigger the star is less the time that they last. We can calculate when one star ignite. We can calculate by the size and the temperature. We can calculate how long it's going to last. We have that technology now. So it's very important to understand these things, how the suns form, and then along come the planets later on. We have seen those formations of the solar systems, how they form with the planets around too, when they just beginning. So the planet Earth formed about most of the planets formed about 4.5 billion years ago. And in those 4.5 billion, after 100 millions, we have evidence that the ocean, we already have oceans at the time. Those oceans, they have bacteria. One of those bacteria that they call cyanobacteria that still exists now. And this bacteria were doing the photosynthesis, protected by the waters. Okay, because in the land, the planet was toxic, totally toxic. There were not oxygen, carbon dioxide was dominate, and also ammonia and some other gases that come from the formation of the planet, like volcanic sulfurs and all kinds of toxic things. So the life didn't have any chance to that. But in the water, it was protecting this bacteria from the sun, from the rays, It was protected by the water of the oceans. And this bacteria was making photosynthesis. Photosynthesis like the plants. And they were absorbing in their body the carbon dioxide and was releasing at the time oxygen. This oxygen that they release, it was forming the atmosphere. The calculations have been done that it's about 3 billion years to form the atmosphere. Then after when the atmosphere about to 650 million years ago, it was complete. There was another procedure that took place. It took another 750 million when the atmosphere already was complete. Then the ozone layer formed. It took about 100 million years to form the ozone layers. The ozone layer is a layer, very tiny layer that exists in the middle of the stratosphere. The layers of the planet. The first is the troposphere. It comes from the ground over here to 15 kilometers. It's where 95% of the gases exist. And it's where you see the aeroplanes, where they fly in those 15 kilometers. And then the commercial lines is from about to 11 kilometers. Then we have after that, the troposphere, we have the stratosphere. That is from 15 to 50 kilometers. And then the stratosphere, the mesosphere, that is from 50 to 85 kilometers. And then from 85 to 600 to 300 is 600 is the thermosphere. And then from 300 to 1,000, this is the other cap, there is exosphere. And those are the layers that we have in the planet that make possible the light that we have over here, and make possible all the interchanges that we have, with the atmosphere and with the environment. The oxygen that we breathe is in this atmosphere. It's a shield that protects us, from this layer protects us from the deadly ray that comes from the sun, or cosmic ray. And also there's a magnetic field. There are two big magnetic fields that we have in the atmosphere. One from 1,000 to 5,000, and another one from 60,000 kilometers. I'm talking about kilometers to 25,000 kilometers. There's those big magnetic field that they generate in the center of the planet, and this deflect most of the rays that are little for the light. So now you see, have general idea how this is happening. Why we tell you this? Why I tell you this? Because very important that we're learning. Very important to know where we come from, the atmosphere. How the atmosphere formed. So we have more appreciation of this, and we don't start to destroy the thing that is around us that cost so many billions of years to do. So this is a beautiful planet that we have over here. It's an immense complexity that we have in order for us to have this light that we have now. It's immense, the complexity that the atmosphere, interchange the gases, that we have in with the atmosphere, make possible the light, evolve the light, being millions and millions of different species that we have in the planet. We have sometimes that happen mass extinctions, at the level that the 75% of the species die, and then another species start. One of those, by the way, going to tell you the mass extinctions. We have some mass extinction that exactly 6 mass extinction that we've been having in the planet. Some of them were at the molecular level. But each time that this mass extinction happening, another kind of molecule, more advanced, came more advanced and more advanced, and then bacteria also growing, evolve, and at the end is what we are now here. We see the evolution of this species that we have now, but it took a lot of time for those. The mass extinction, the first one is about 2,900 million years ago, happened one of the first mass extinction, uh, 22,900 millions. That's not billion year. We have the Silurian. Then we have the Silurian mass extinction. Then we had the Devonian mass extinction, Permian mass extinction, Triassic mass extinction. We have and then we have the Cretaceous mass extinction when that's big asteroid hit the planet about to 65 million years ago, and that's one of the last mass extinction that exists. At the 75 to 80% of the devastation of the planet with respect to the life. This asteroid hit in the Yucatan Peninsula in Mexico and was the one that destroyed the dinosaurs that they already have 160 million years in the planet, and then suddenly they just went out of the life in the planet. A new species evolved until the one that we have now. And the top of the line that we are here now, and our species just at the beginning of the species about 3.5 million years ago, we have some evidence that there were some species that look like us, but really about 300,000 years ago we can trace the DNA that we actually have now. Some other species remain at about 30,000 years. The Neanderthal men disappeared too, and then we were alone because we were about 20 different species that look like us, but they didn't have exactly the same DNA. So now you have the history, a little bit of the history, just to give you some clues, and then perhaps you can advise your kid and yourself to try to understand the things that is so important for the humanity to understand. We have this big brain that we have now, and most of the time we don't use the full capacity of the brain. So it's very important that we start to exercise that brain, because if you don't exercise like the muscles, they just disappear, and then people become with Alzheimer's diseases, Alzheimer's disease, and many other diseases that take in account that if we don't do exercise, we lose the muscle. Same with the brain. Thank you very much for your attention, and I hope that you follow the channel, and we're going to continue this kind of content. Thank you.